Okay, ABCD is a trapezium. DC equals 3AB. So we've got one vector being a scalar multiple of another there, which tells us that they're parallel. DA is minus 2, 3. DB is minus 1, 7. Find the exact magnitude of BC. Okay. Well, BC, we can... With all these, I really do think that the key is to write them in terms of sums of other position vectors you've got. We know that BC is equal to BD plus DC, because we're starting at B and we're ending up at C. So one way or another, when we write that out and simplify it, it's going to be equal to BC. Now, we haven't got BD, we've got DB, but we haven't got BD, and we haven't got DC yet. So we've got to find out what AB is. So let's just find out what AB is. AB, in the same way, is equal to BD, sorry, I'm doing it wrong here, beg your pardon, is AD plus DB. And we can find that quite easily because we've got DA. I mean, if we negate it, so element-wise, we get 2 minus 3 instead of minus 2, 3. That's therefore the other way. We're going the other way. And DB we've got is minus 1 and 7. And so that is equal to adding 2 and minus 1 is 1, and minus 3 and 7 is 4. So we've got AB, and B to D we can find by negating D to B. We know that DC is 3AB, so I think we're already there. So if we say BC equals BD plus DC again, then BD is 1 minus 7, and DC is 3 lots of 1, 4. And that is equal to 4 on top, because we 1 plus 3 ones, and then we've got minus 7 plus 12, which gives us 5 on the bottom. So we've got the vector from B to C. Now the magnitude of BC, which is written like that, is just the length of the vector. And it's very natural to use Pythagoras theorem because this is a shift in, a change in x over a change in y. So we can immediately just say 4 squared, let's do that neatly, 4 squared plus 5 squared, which is equal to the square root of 16 plus 25, which is 41. And that we can immediately see can't be simplified because 41 is a prime number. So that is, it's also exact because we put it as a surd. If we'd stuck that in our calculator and come up with a non-terminating decimal, as all surds will give you, obviously the calculator chops it off. So even if you had written out every single digit in your calculator, it would not have been exact because you would have chopped it off. But left as a surd like this, that is exact.